everyone. I'm Blake. I guess I am giving you a talk today on cluster computing. Yay, let's just minimize all this stuff to get to the PowerPoint, and we start with that. How do I make it go on one screen? Let's see.
Double click the first frame.
Start from the beginning.
Yeah, sure that works.
Alright, and so, I guess, what is a computing cluster? A computing cluster is a set of loosely or tightly connected computers that work together. In many respects, they can be viewed as a single system when they're performing tasks. Usually, they're controlled by a head node, and then they have slave nodes, or a leader and a follower, if you want to be more correct and not piss people off. The two of the major platforms for cluster computing are Apache Hadoop, which is a framework for distributed storage and distributed processing. And then there's also Beowulf, which is a scalable performance cluster based on commodity hardware that usually uses message passing interfaces, which are usually written in C. So basically, Apache Hadoop is for higher level stuff. Beowulf is for lower level stuff. And if you're going to be doing stuff, I guess, Beowulf's a lot faster. Hadoop is slow but big. And today we're going to be talking mostly about Hadoop and one of the modules that runs on top of it called Spark. So here's the basic parts of Hadoop. Hadoop Common, which is just libraries and utilities running Hadoop. Hadoop Distributed File System, which is why so much stuff runs on top of Hadoop, because of the distributed file system that Hadoop provides, which is really useful for a lot of things, because you can create redundancy within it, so you don't need to it creates its own backups, and it distributes files between the nodes and everything, so it's just really useful for if you're dealing with large amounts of data. And then Hadoop Yarn, which is yet another resource neighbor or whatever. And that's just a resource management platform for managing resources. And then MapReduce, which you may have heard of before, which is what actually disseminates the job between the nodes. So if you think of cluster computing is a lot like, have you ever made spun up threads in C? It's not the same, but the idea is similar. You're just distributing jobs, except for now you can distribute it to whole CPUs rather than just other threads.
Do you have to worry about Unix this much?
What?
Do you have to worry about Unix?
Well, supposedly MapReduce is supposed to take care of that for you and all that stuff. When jobs are completed, and in Spark it's called parallelize, and it's just takes a bunch of data and then it chops it up and then gives it parts to each node and then runs the tasks on each node. So, and like I said, we're just going to do mostly Spark here. Spark can actually run pretty much without Hadoop. The only reason that you use Hadoop with Spark is because of HDFS and the distributed file system, which you technically don't need, but if you're going to be 9 times out of 10 you're going to use HDFS. But the main reason we're going to talk about Spark so much is because you can pretty much just install Spark on your own computer and run it as a single node and learn a lot about how Spark works without having to go out and set up multiple computers or multiple VMs and hate yourself. And so Spark versus Hadoop. Spark is faster than MapReduce because of the way it processes data, and while MapReduce operates in steps, Spark operates on the whole data set in one fell swoop. And Spark is also a lot easier to use than Hadoop. It's just, I don't know, I haven't had any fun with Hadoop, mostly just because I don't like XML configs, but maybe someone else here likes them.
Nobody likes XML.
Yeah. Alright, and one benefit of Hadoop, though, is that it has slightly better security. But that's just because it's been around longer, and more patches have come for security vulnerabilities. Basically, if you want to learn something, learn Spark because it's newer and it's probably going to be the next big thing in cluster computing. I mean, well, it already is, but MapReduce is kind of going off the, it's a dinosaur pretty much in the cluster computing world. And another thing is, Spark can run Java, Scala, R, Python. Hadoop by itself just runs Java, which is kind of, not very useful. It can run other things on top of it, but not really. And so we're going to talk about my cluster setup because I've been working on this way too much. So the framework that I used was Apache Spark, like I said. And then another thing that's somewhat important when you're setting up a computing cluster is a configuration management system so that you can easily deploy things to each of the nodes. For that I use Ensemble because it relies on SSH keys. And by the way, if you're ever doing anything with cluster computing, please know how to do SSH key gen and just the simple Linux how to communicate between servers. I don't know. Right now, I just gave the same presentation yesterday to people that had never SSH'd machines before, and it was kind of sad. I don't know. I don't think they got anything out of it. And so for monitoring, I use Gangula, which is really nice for you can compare the process usages of each machines and make sure that the loads are getting distributed properly. And for distributed file system, I just use HDFS. So yeah. Anyways, here's the Spark Web UI. We'll go over this more later since I'm going to do a live part after this. And here's Gangula graph example. As you can see, all the nodes are listed along the bottom, with localhost being the master node. And that's just the aggregated load. And then the ways of using Spark are you can do a Spark submit or you can do Spark shell. And Spark shell is really useful because it lets you interactively type in Spark code, so you don't need to just run a job every time. And a nice library to use with Spark is GraphX because it lets you view things in a large graph easily. And here's my parallel prims algorithm stuff that I did for my algorithms class. I just included this just to explain that sometimes you don't want to parallelize things. Because if you do, the communications between the servers just ramp up, and pretty soon you just end up with a job that would have been a lot easier to do on one system. So that's what happened with that one. And oh yeah, I included this just to show you why you should actually learn Spark, because you make a lot of money. A lot of money.
That's average.
Yeah, I mean, I pulled that straight off Google. I don't know. I just pulled it off Google.
Is that the money?
Yeah, I think it's money. You make good money if you learn Spark.
How many months?
I don't know. Much money. Anyways, rather than any questions, we're going to go on to the live part of the demo because slides are stupid. Yeah. Where'd that mouse go? Oh man. Well, I am duplicating this. Darn it. Alright. So, for the live demo, I'm going to show you Spark Shell and Spark Submit. And first of all, let's start with my GitHub repo, which I've been working on for my senior design. And okay.
Wow. Maybe we can go on that one on GitHub.
Anyways, so the idea here is that I'm getting the configs organized and everything so that anyone can set up their own Hadoop Spark cluster without trying too hard. Because right now, unless you're running it just a single node cluster, everything's really annoying. Like, you'll find different configs for everything out there, and it's just really frustrating to work with. I was still fetching my last commit. I don't know why. Come on. Alright, and then, so let's get on with this. I wrote a bunch of scripts, I have a bunch of demos, I have a bunch of configs. Let's go into the Scala demo. Yeah, stay right here. And then, so, let's do a Spark submit real quick. So, I wrote a really nice script that basically it just makes it so that you only have to put in the class in the name of the folder that you're pulling the demo from. So we're going to run just a Scala demo. So I'm going to do so what that just did was that took the lines in this README right here and it counted, let's go with it counted all the A's and it counted all the B's. So in that, all the lines with A, there's 61 lines, all the lines with B is 27. Now I'm going to go ahead and just turn on the info log just to show you how annoying it is. And because right now I have just the error log, but if you have info log on, it gives you all of this crap. Spaghetti, yeah, it's great. So first things first, it looks complicated, but it's actually not that complicated. It's just really annoying.
Oversee that.
We'll go back to it. Alright, and so now we're going to go ahead and do a Spark shell demo. Waiting. Yay. Alright, and so for this I'm going to need for that I'm going to do this GraphX demo right here. And there's a picture of what we're creating right here because I have trouble visualizing it. So in here we're going to do some imports for GraphX. Now this is just so that I can show you how you can take anyone's code for Spark and just put it in line by line, and then it's a great way to debug it so that you don't need to just sit around and wait for a Spark submit to complete, because some of those could take a really long time. And I have no idea what that. Oh, okay, it's fine. There's no errors in there.
So what you're saying is you can unit test things?
Yes, you can unit test things really easily. And like I said, just you can run a standalone cluster in Spark. You don't need to worry about Hadoop. And so you can get started without having to do too much work. I just copied the wrong thing. So it just parallelized that right there. Parallelize the vertex array. Now it's going to parallelize the edge array. and it gives you the partitions and everything of each one. And so now I'm going to start up the graph. And now we're going to get everyone that's age is greater than 30. So if you look here, there's 4 of them that are above 30. So we should do 4. Yay! What? No, this is secure shell. It's a Chrome plugin. Yeah. I don't know. It's probably not as secure as it could be, but it's what I use. So now this is giving a relationship of the people in the graph. So Bob likes Alice. Bob likes Dave. Let's see. See, Bob likes Dave. Bob likes Alice. And then you got, like Ed likes Bob, Charlie, and Brad. So, as you can see, this is great for if you're doing graph-related stuff. Just sometimes don't try a parallel algorithm where you shouldn't, or I don't know. And that's for other this is for relations for other relations. So like Bob likes Alice a lot because, as you can see, both paths lead to Alice here. So Alice is an end node. And then Ed loves Charlie because oh yeah, because what?
Because the edge weights are so large, they're above the 5.
Yeah, it's the edge weights. And, yeah. Yeah, sorry, I forgot. That's what that was actually. Yeah, because the edge weights are greater than 5. That's what it is. Right here.
And those are done in parallel? Those computations on a graph?
Yeah.
Oh, okay.
Because the graph was parallelized. So, yeah. In fact, I can show you that part now. Now that we're done with the Spark Shell demo. So here's one of the ones that got parallelized right here. This is actually not the job we just ran because the jobs that we were just running were on my new server, my new cluster. This is from the old cluster because the old cluster has HDFS set up properly. My new cluster doesn't because I haven't gotten around to it yet. But for some reason, there's something wrong with Spark on the old cluster too. So, Alright, yeah, I'm good. I'm about done anyways. Before I take questions, I'm just going to show you the sites real quick. So this is the site for Spark. As you can see, I have 3 workers up here, and then I have completed applications down here. It gives you a nice, pretty, interface. Shows you running applications and completed. And then it gives you a timeline, and it gives you a nice visualization of what was done where, and so on and so forth. Now for Hadoop real quick, I'll show you the I'll show you them. So these are both the nodes in HDFS. And then for Yarn has its own site too. Freaking so many websites in this. It's kind of annoying. Here's Yarn, and I guess I was Gangle. One last thing. Here's the loads for the servers. Okay. Maybe something's not balanced. I'll figure that out later.
Question.
Questions, guys?
So, what are the real-world problem domains that you would tackle with like Hadoop versus Spark?
Well, I think when you're processing a lot of data, like, I don't know, just like doing web scraping for something, I think that would be something that you do. I don't know. I actually haven't done any real world applications of Spark yet.
Alright, any other questions? Would you ask a question?
Is there a difference between cluster computing and parallel computing?
Yeah. So I guess parallel computing is more along the lines of, isn't that when you have a blades and then or am I thinking the wrong thing?
Well, they say CPUs and their speed is not important anymore because parallel computing has taken over the big crunch jobs. But it seems to me cluster computing takes over the big crunch jobs. If you're doing big data with cluster, it seems like the way to do it.
So, like, I would call cluster computing a subset of parallel computing.
Yeah.
Any other questions? Alright, thank you, Giggles.
Woo!